Welcome back, geometers. 1, 2, 3, 4, 5. All right, cool. So here we are. We're trying to write a proof to show that serve is congruent to what? Cool. Well, I'm stuck already. Carson, I know you can answer this one. How do I start a proof? With the givens. And I just want to remind you guys, because depending on you and my specific rapport, I think I have a pretty good interaction with most people. Very few. I can think of very few situations where I've had a negative interaction from my perspective. With that said, do we always have the exact same perspective on stuff? So I just want to continuously remind you, if I'm bullying you and I'm rude and I just don't know it, please tell me. Cool. I was trying to mess with you, but not in a rude way. I didn't think you took it as rude, but I just want to verify. All right. Well, the givens. But they didn't write any givens. Oh, no. I hate it. Disagree. I like that idea, but the teacher part of me, not a chance. Are we using letters or numbers? What did you guys use? Okay, so let's just use letters so they all match. I think that angle SWT is congruent to what? SWT. SWT, and I would call it TVS just so I don't start at the same spot, but can you call it SVT if you want? Yeah. Okay, so I've gotten these marked, and I'm just going to mark them with orange as I do it so I don't forget I've done it. Okay, anything else that we know? So angle R and angle U are right angles. Anything else? And rather than anything else, Vincent, give me something else that we know based on these marks. How about I start and you finish it? Because oftentimes that's the hardest thing. I'm going to make a claim that segment RS, guaranteed Vincent, is congruent to what? RS, UT, you got it. And there's one more, only one thing that I haven't marked on this picture. Raylene or Carson, what you got? Either one. Okay, I'm going to pick one of you guys. Raylene, do you know the answer? With whether you're looking at your notes, real quickly, I'm going to say just look up here rather than your notes, because you might have it in your notes, but just because you could do it yesterday doesn't mean that you can do it today, and that's okay, right? But I want you to practice with it. Are there any more marks up on this that I haven't mentioned yet? So what is this indicating? That is a what? And how do you name that angle? If I just say angle S, do you know if I'm talking about that or that or that or these or I don't know, right? So how should I name that angle? I'll start at T. If I want this angle right here, I go from T to where? Good. So T to S to where? Cool. Or V. Either one would be fine. I'm going to go to X. That's cool with me. Angle TSX is congruent to what, Ashley? Look for that last angle. Good. I'm okay with that. Awesome. Now, for this, Ray, I just want you to know, I very much would have liked to do exactly what you suggested and just say givens, but we do it formal. All right, so here we are. Now, a good approach to proof always is to make sure that we know what we're talking about, because there's a ton of triangles on this picture. We all agree with that. There's a bunch of them. So we're going to try this colored pencil, and we'll turn down. I hate that it doesn't change it because it still calls it ink flow. But I'm just going to shade in the triangles that I'm actually focusing on so I don't get lost. I'm trying to show SRV, which is this triangle here. So I need that triangle to match with, let's see, TUW is this big triangle. So those are the ones that we're looking at. That's what we're after in the end. Now, the picture here becomes even more valuable. Like, legitimately, it's going to happen. Now, there's a few things that I notice. As I look at both of those big triangles, can you guys tell me anything about them? Like, specific about those triangles? And just to be ultra, go ahead. You guys agree with what Ray just said? The big triangles that we just drew are right triangles. And why would I focus on that? Why would I care that they're right triangles? Do we get anything different compared to all the others with right triangles? What? I was hoping Russell would yell it out from the gym and we just happened to hear it by pure coincidence. It did not happen, unfortunately. Why do we care of the right triangle? What have we did with right triangles? What have we done, rather? So the Pythagorean theorem, we did use it, for sure. And we used Pythagorean theorem the other day in class to work out a specific shortcut for these. What was it? If we could get the hypotenuse of these two triangles, I think we'd be okay. Because what I realize is that this is a leg of the triangle, and it's congruent to that. And this is a right triangle, and that's a right triangle. So right now, just before I do anything else, my thought is, if I have a way to show that SV is the same as TW, my hypotenuse are the same, then we're fine. And I would have the proof done. Okay, so that's where my mind goes. It is not the only way to do the proof, but that's the first thing that I see. Does anybody see a different thing that you notice, just as we kind of think about how do we work with these two triangles? Okay, and that's fine. Like, I'm good with that. But check this out. Our goal then, currently, if there's nothing else, is we need a way to be able to say that this and this are the same. Like, that's the goal right now then. Now, if I just look at one of them, this is a single segment, but is it made of smaller segments? Raylene, which smaller segments is it made of? And I'm just going to write that. Like, I need to deal with this. So in my head, I'm already thinking, well, how do I, first of all, get it less bold? But how do I get these in my proof then? And I think that, oh my goodness, last try, here we go. Boom. I think that SV, that segment, via addition, is made up of two smaller pieces. What make up SV? SX, so if we take this and add what to it? XV. Everybody agree with that statement? That's true. Why would I do this? Like, what's the point of me writing this? I like both of those answers. You misunderstood the question, but that's okay. You told me that this was angle addition. And Ray answered the question with, why do I want these? Because I need to show that hypotenuse are the same, because then we can use that shortcut. So both questions just got answered. What is the justification and why? Is there another angle addition that might come into play here? TW, this whole segment, the other one that I'm after, is going to be equal to TX plus XW. Okay, because I'm going to use it anyway, I'm just going to sneak it in on line B since it's also angle addition. All right, so that's all fine and dandy. But I don't know that we have that yet. Huh. Well, that's okay. I'm stuck. I need a way to verify that these two are the same, because that's our end goal right now. If we can get these the same, we're good. Well, should I just throw in the towel, give up? I don't see anything. Good call. No is the right answer there. How can I make sure that these are the same? Not rhetorical. Before I just awkwardly wait for like 20 seconds then answer the question myself, I'm going to give you guys the next 30 seconds, talk with each other. Ideas are ideas. That's what I want. Hopefully they're good ideas, but might not be. That's okay. 30 seconds, I'm going to call in somebody random. Talk it out with your neighbors. Physically talk. If you and your neighbor aren't talking, go talk with somebody else. have a decision to make. I would like to be really formal, but I would also not like to have to use 26 different letters of the alphabet, right? Like we wouldn't use 26 on this, but can we conclude this is true and try to maybe add 2 justifications on one line? How do I know this is true? Because I agree with you. And I've marked it, so as soon as I put a mark here, I'm going to write it here. I'm confident that SX is congruent to TX. And TX. Say it again. Good, I appreciate that. Why? How do I make this? Because we did like 2 or 3 really logical things. We recognize that this is isosceles. I'm not going to write that this is an isosceles triangle. I'm just going to work with the assumption that it's going to be clear based on the justification. If this is an isosceles triangle, what theorem allows me to go from that angle to that mark? Or these angles to these marks? What's that theorem called? You're going to be right, I think. It's the isosceles theorem. That's it. Like, it's the fact that it's an isosceles triangle. That's the isosceles theorem. The base angles and the sides are the same. Okay. Now, realistically, we also used, like, the only line that we skipped is writing that this is isosceles and then applying that theorem, but we did it. Okay. Well, that's a pretty good sign. Is that the entire piece, though? Like, is it really, though? Like, obviously not. Okay. Well, I'm still stuck, but I think that's a good start. Do we need to keep doing the 30-second thing? Okay. Do we really, or are you just trying to kill time? We're going to spend 30 seconds awkwardly waiting anyway. Turn again. I want to know another truth. Something else. My goal, I assume we have the same goal, but maybe not. I'm looking at WX and VX is where my mind goes, whether or not we wind up using it. For which triangles?
For TWU and SVR.
So first thing, not quite, and I can't use your marks because you don't have them, Andrew, but this mark that we have right here is only this segment. We can't use the whole side. Even if we did have the whole side, notice we would go from an angle to a side, and you would not feel great about it. Although somebody might have just made the same conclusion over there. I can't tell.
By the way, I did solve it differently. I just was like thinking.
No, I like it. I'm okay with different.
There is actually a faster way.
So I'm sure, and yep, we're good. Again, we meet in between, right? Theoretically. Okay. I need something else to write in my proof. We're already this far in.
Angle SXW.
Angle SXW. So you're looking at this one. Why is this a handy angle to have? Not Ray. All right. I can't tell. Is it silent because nobody knows or silent because it's silent? Okay. Check it out. We need to bounce around triangles is ultimately what has to happen. Now, I'm trying to get to this is the same as this. That's what I need, right? Now, here's the cool part. What Ray recognized is that even if he didn't see the immediate end of this, anytime that you know something is true, you're probably going to be better off for writing it than not. Now, if your concern is only efficiency in proofs and writing as few lines as possible, you likely won't do that. But unless you can see the whole proof the whole way through, you shouldn't do that. Like, it's okay to be focusing on efficiency, but I'd rather focus on let's just make sure the ideas are good and then get better at it, rather than just saying let's do it the best we can immediately. If there's something true, we should write it. This angle is congruent to this angle. Why? Did you know that that was the answer as soon as we put this mark here? So what should we do, anybody who just nodded yes? That or answer the question, or both. But cool. Now, at this point, since we're probably all in the same, do you want me to name it SXW or can I name it angle 1? If you've already called it SXW, you're fine. But since we're doing this proof together, I would call it 1 and 2. I'll tell you on proofs and stuff, I will make sure to label angles for you so that we can do it easier because I get lost in the letters. I immediately do this. Okay, angle 1 is congruent to angle 2. Why? How do you spell vertical? So everybody can do this part every time. What are the last 2 letters? A-L. Okay. And I'm okay with just vertical, honestly. There was a hint of a joke in there. Not a good one, but you smiled. Maybe you're just happy. I don't know. What's that? Oh, was that you I was calling out? A lot of people do it, just so you know. Cool. Well, why do I care that those are vertical if we look at little triangles in the middle, diagonally slanted? What can I say about this triangle and this triangle? Why? We have a angle, angle, side, and we have a angle, angle, side. Hey, those triangles are congruent. Okay, this one, we can't just use letters and stuff. E. Let's see. I don't know. How would you name this triangle? Okay, I would call it differently, but it doesn't really matter, right? SWX. As soon as we commit to, I would start here. I'd go double 1, 2 is how I would do it. But SWX matches up with what? How do we do none, double, and weird? TVX. Okay. And check this out. Here we are. How do I know that? Angle, angle, side, or ACE congruence. Okay. We are so close to being done. Now, remember, I'm not going to give you like 40-line proofs ever to do on a test, but in class, it's nice to work harder problems together before you try to do easier ones on your own. Okay. Why did we care that these triangles are congruent? What was the end goal? Like, we already have these parts. We've been saying all along that once we mark these, if I could get these the same, we'd be fine. Do I have enough to say these are the same now? Why could I confidently say that WX matches up with VX?
SVX and TVX are all there.
Are you trying to CPCTC me right now? Okay. We're using the fact that these triangles are congruent and that the corresponding parts must also be congruent. I'm going to check my statement real quick. Did W, and let me rephrase that, did XW line, I'm using a black marker, did XW line up with VX or XV? Yeah, so are they the same? For sure. Here we go. We're almost done. F, I'm pretty confident that WX is congruent to VX. And that is CPCTC. Okay, the end is in sight. We are so close. Right now, we said that at the very beginning, once we highlighted these triangles, all we really needed was the hypotenuse. And we said even right away that the hypotenuse is made of these pieces. If I look back at this very first line, instead of SX, what could I write anywhere in here? And that's not B, this is G. SX, somewhere in this proof, we say SX is the same as this. TX, and it's right here. So I'm going to rewrite this line. SV is the same as, instead of SX, it's TX, because we said they're the same. Okay? And then instead of XV, what could I possibly say is the same as XV somewhere? One more time. You were right. I didn't hear it for sure. I'm pretty sure you're right. XW or WX, because that's the same as XV according to this line. Okay? So WX. Now, we are kind of being fast and loose with formal notation. The only thing that we didn't include that I don't really think we need to is congruent and equal. Like, they are different. We should use different symbols. But I'm just using the fact that congruence means equal. And I'm not writing it down. We're just using it. And then last step for getting these two pieces. Do we have another way that we can refer to tx plus xw? It's tw. That's from right here. Now, I'm just going to do these both on the same line because I think I'm doing the same thing. This is now tw. In both situations, I substituted here. And then did I also just substitute again? So what's my justification? Good. I was not expecting it to be blank there. All right. Now we're close. If we want it to be fast and loose, could we just say that, hey, yep, these are equal. It also means they're congruent. I'm still going to count it as substitution. We are one line from being done. If I draw this and I make it like really bold so it's easier to see, if I have this triangle and I have a mark here and it's a right triangle and I'm going to do this mark because it's obnoxious and we can all see it. And that's just for the whole side now. And this triangle that also happened to have a right angle and a mark, and this whole side was the same. What two parts of the big right triangle did we just show were the same? The hypotenuse match, and there's one more piece. The leg. So I'm always going to look here. This is what I'm going to write, and then I'm going to look at my picture to get the other half. Triangle SRV. H. Gross. Triangle SRV. And I'm not just looking at the statement that I know we're supposed to end up at. I'm actually going to look at my triangle. S to R to V goes blank to right, or 1 dash right angle blank side. How do I go 1 dash right angle blank side? Is it TUW here? And that's what I'm going to write, and then I'll scroll back up because I can't see on mine. Is that what we were supposed to prove? Oh, baller. Heck yeah for H. What's my justification? This is hypotenuse leg, congruence, and we done. Okay. This proof is pretty big. Now, I'll come take a look at yours, Ray, because I'm interested. Like, I'd like to see it. I just want to see what you did, and I'll make sure that you're cool on it.
I got to G, but I only wrote E because I skipped 2. I wrote them down after.
Did we do the same logic? You just have different formal structure?
No,
Okay.
got to the end
I'll come. Okay, I'll come look at yours here in a second. Okay, this proof, a little bit longer. Each individual piece, I don't think is wildly challenging, but obviously if we, instead of just having 2 triangles right next to each other, if we have a bunch of triangles like we do in this picture, we have to be more careful with how we pick it out. And there's a reason that we did that thing yesterday with the art that I really like and I can make. Cool. All right, for that, we done. We are done. Cool. We just finished 4.6. We are done. Cool. What do you think we're going to do tomorrow? Practice test. Yep, or team test, wherever you want to word it. I'll let you guys play by ear. How many proofs do we want for homework? Because that's all we did today was one giant proof. Your proofs will not be as giant. 1?
Wasn't this homework?
Technically. So I'm not going to give you this proof on the homework. I want you guys to do for me. Oh my gosh, I love all the problems. Your book tells me that I should give you 12 through 29. That's what your book suggests. I never use your book suggestion because I think it would take way longer than necessary. But I do like several types of problems. So, for your homework this evening, you get the privilege of working homework 4.6, and you will find this waiting for you lovingly on page 193. On page 193, I want you to do problem. Sorry. Yep, we're just going to do the nicer version of it. We're going to do 12, 13. I should have said 12 through, nope, I lied. We'll just do 15. And then 17 through 20. And I'm going to let you guys pick. When you open the book, I want you to tell me, are we doing the proof 21, 22, or 23? I know which one I want to give you, but I'm also pretty sure it's not the one that you're going to want. Yes. The question at hand is, are we doing proof 21, 22, or 23 on page 194 ultimately?
I go.
You think 21? Okay.
Oh, I did a vote.
Nope, I'm cool with that. We're doing 21. 21 or 22 was easy. 23 is the one that I would have done. Really important. On 21, they say write a proof. They don't specify. What kind of proof are you going to write? 2-column. Do not write a paragraph proof. Raid, the same one that we always do, where we have 2 columns.
Oh, okay.
Yep. Cool.